Hey guys, today we're going to be looking at some math trig identities from IB course, and especially we're going to be focusing on the cosine and sine rules. And so here we have our first question, where sine x can only equal to 0. I mean, obviously this because it's in the denominator, so we can't have that equal to 0. Now, in order to approach this, we gotta realize that cos 3x, there's absolutely nothing that we can do with it. There's no specific rule for 3x. I mean, there are, but none that are currently will be helpful. So, but there is a rule that we do know, which is cosine of alpha plus beta gives us cos alpha cos beta minus sine alpha sine beta. Okay, so with that in mind, we can see the 3x and we can split it up as x plus 2x, and obviously we keep the right side the same for now, although we are going to change it a bit later. Okay, so let's open it up. I'm not going to rewrite the right hand side because no, it's not quite useful for now. So cosine x plus cos x cos 2x minus sine x sine 2x. From here on out, we have 2x and 2x. So immediately we can tell that it's the double angle rule, which is for sines, sine 2x equals to sine x cos x. And for cosines, I mean, there's a bunch, but cos 2x, the one we're going to be using today is 1 minus 2 sine squared x, if I'm not wrong. Okay, so let's open this whole thing up and see what we get. Cos x plus cos x times 1 minus 2 sine squared x minus sine x times 2 sine x cos x. Okay, so let's then open the brackets and get the full version of what's happening. As you can see, there's cosine in every single one of these additions, so we can take the cosine out and we can have cos x times 1 plus 1 minus 2 sine squared x minus 2 sine squared x. Already it's looking much more prettier than this thing in the beginning. Let's further simplify it. Okay, so now that we got this much more prettier version, let's again look at the right side, which is sine 4x to sine x. We're gonna now a bit modify it. We're not gonna really change it as much. We're just gonna open up the sine 4x as sine 2 times 2x and 2 sine x. 2 times 2x. Now what we know is that sine of 2x is, oh, it's this. So then we can write this sine 4x equals sine 2 times 2x as sine 2x cos 2x times 2. But this we can again open up as sine 2 sine x cos x, wait, times 2 again here because of this 2, cos x cos 2x. Now this does look quite ugly, but it will come together. So let's write this all out. Sine x cos 2x. Let's not forget the 2 sine x at the bottom. Let's open sine squared x, 2 sine squared x. Now this, as you can see, is cosine of 2x. So we can then say that left hand side equals right hand side. And that is how you do this trig identity. Okay, so here we have our next problem. This one again for identities, but a bit more just in general trigonometry. It's r cos of x plus arc cos of x root 8 equals pi on 2. Okay, so here we can see we have again cosines, arc cosines, and we have pi on 2. Now, what is important to realize is that whenever we can make one of the sides equal to 0, we want to do that. Okay, so let's make a table of all the cosine values for different standard angles. I'm going to write them in degree form, but you can obviously easily convert them to radians. 0, 30, 45, 60, and 90. So let's rewrite this equation, but this time cosining both sides. So cosine of arc cos x plus arc cos x root 8 equals cos pi on 2, and this equals to 0. Okay, so then again, as in the previous example, cosine, we can use the cosine of alpha plus beta rule to get cosine alpha cosine beta minus sine alpha sine beta. As in the previous one, we have alpha here and beta here. Okay, so since we have this rule on the left side, let's open it up using the rule. We get cosine of arc cos of x, cosine of arc cos of x root 8 minus sine arc cos x sine of arc cos x root 8 equals 0. Now this is quite ugly already because we have the sines of arc causes, but we'll get to it shortly. This, as from a previous example, just simplifies into x times x root 8. This we can drop over to the right side, which is the benefit of having a 0 on the right side. And so we get sine of arc cos of x, and then sine of arc cos of x root 8. Now, sine of arc cos seems quite impossible to do, but it's important to remember that arc cos is an angle and arc sine is an angle. Anything arc, it's an angle because it's an inverse of a trigonometric function, which gives us an angle. So let's do this in trigonometric form. If we have sine of x equals, let's say, in this case, let's actually use x. Actually, no, let's use 1/2, right? So then if we take arc sine of both sides, arc sine of x equals arc sine 1/2. This simplifies to give us x equals arc sine of 1/2. So in this case, when we have arc cos of x, we can draw a triangle. In this triangle, this would be arc cos of x, right? And we're going to take a sine of it. Now, since we know that arc cos of x is cosine of whatever gives us x. So let's put alpha. So cosine of arc cos of x gives us x. Now, cosine is of this angle would be, since it's a 90-degree triangle, would be adjacent over the opposite, over the hypotenuse, sorry. So since we don't have a denominator here, it's 1. And from that moment on, we can already say that the hypotenuse, which we have right here, is 1. If it's 1 and x then is the adjacent. Now since it's a right angle triangle, we can easily find the opposite of that angle. So that would be 1 squared minus x squared all rooted, which would give us root of 1 minus x squared. That is the value of this side. Now to find a sine of this angle would mean to have the opposite over the hypotenuse. So the sine of arc cos of x would mean to have root 1 minus x squared over 1. And so this whole thing, which looked quite ugly, immediately just turns into root of 1 minus x squared. Let's rewrite that from the beginning. Let's put x squared over 8. Now exactly the same process is done for this side, and let's draw a triangle for this side. We get 90 degrees. Here we have arc cos of x root 8. So then cosine of, let's say, beta gives us x root 8. Again, due to a lack of the denominator, hypotenuse immediately is 1, and since this is a cosine of this angle, then the adjacent will be x root 8, and using the Pythagorean theorem, we get 1 squared minus 8x squared rooted, which gives us root of 1 minus 8x squared. Okay. Since we have 1 minus 8x squared rooted, let's again plug that in instead of this part. So we get x squared root 8 minus 1 minus x squared from this triangle multiplied by 1 minus 8x squared, 8x squared also rooted from that triangle. Now this is much easier to work with, and in fact, since we have roots and only multiplication, we can easily just square the whole equation. So we'll get 8x to the power of 4. Now don't worry about the power of 4, we're going to deal with that soon. Gives us 1 minus x squared times 1 minus 8x squared. Let's open this up, this bracket, and simplify it, and get 1 minus 8x squared minus x squared plus 8x to the power of 4. Now since we have the x squareds and 4s, we can substitute x squared, let's say, for alpha. And so we get 8 alpha squared equals 1 minus 8 alpha minus alpha plus 8 alpha squared. So this simplifies from both sides, right? And so we get 9 alpha equals 1. So then alpha equals 1 over 9. But alpha isn't the final part because alpha equals x squared. So then x squared equals 1 over 9. So then x equals plus minus 1/3. It's important not to forget the plus minus because you're taking a root of a number. So yeah, that's how you solve this question and find x. Thank you.